Hello, today we're going to talk about turning a regular standard number into scientific notation. Okay. Scientific notation is really used to write big or small numbers that are just really too long to write. So we want to make them a little bit easier to write, and so we would use scientific notation for that. I'm going to use some easier examples first, and then I'll show you why scientific notation is important. So the first thing to remember is that scientific notation, we have to have a coefficient that's between 1 and 10, and then we are going to multiply that by a power of 10. So I'm going to write a number. Let's write the number 742. Okay. So when I have scientific notation, I need that number to be between 1 and 10. So I need it to get to one digit. So I'm looking for the first number that's not 0. So what's the first number that's not 0? Well, that would be 7. So that's where I want my decimal to go. It was originally right here. So I'm going to use red to kind of show you where the decimal went to. Okay. Now we're going to put a box around the numbers that are between the decimals. Okay. Now we know that we're multiplying it by a power of 10. Okay, and the exponent for the power of 10 is however many numbers are inside of that box. So we have 2. Okay. Then we just have to think, is this number bigger than 1? So is 742 bigger than 1 or less than 1? If it's bigger than 1, this is a positive exponent. If it's less than 1, then it would be a negative. If 742 is bigger than 1, so it's a positive exponent. Then we're just going to bring the numbers down with the new decimal, so 7.42. So 7.42 times 10 to the second power. That's all that we have to do. Okay, so let's try a little bit bigger number this time. Let's try 6,300. Okay, and we know that our decimal is always at the end if we don't see it. So our decimal's right there. I'm going to switch colors. Okay, we want to put our new decimal after the first number that's not 0, which is 6. So we want our decimal to go right here. So we're going to box in those numbers there. Okay, and so we have 10 to the third power, because there's 3 numbers inside of the box. And you could count the numbers. It's going to be important to count the numbers if you have a lot of them. And I would put some kind of little notation there over it so that you don't lose track of how many numbers there are. Okay, and then we're going to bring down the 6.3. So we have 6.3. And you could put the zeros, but we don't really need to because it's not going to change anything. So we have 6.3 times 10 to the third. Okay. In the previous lesson, we learned how to convert scientific notation into standard. So you could always work it backwards and double check yourself. And you could say, I need to move it 3 places to the right, and that would give me 6,300. And so you can make sure that you did it correctly that way. Now let's take a look at a number that's less than 1. So let's take 0.0042. Okay, so I want to put this decimal into scientific notation. Okay, so my first decimal is already given to me right here. Okay, so that's my first decimal. I want the new decimal to go after the first number that's not 0. So I've got a 0 here, 0, 0. There's a 4, so I want it after that 4. Okay, so I'm going to have 4.2, because that's what I had here, times 10. And how many numbers are in that box? Well, I've got 1, 2, 3, so it's 10 to the third. But because we had a number smaller than 1, it's a negative 3. So it's 10 to the negative 3 power. Okay, and that's what makes the decimal go to the left. Okay, so The negative makes the decimal go to the left, positive makes it go to the right. So if the number is less than 1, then you need a negative exponent. Okay, and then if the number is greater than 1, you need a positive exponent. Okay, so hopefully this will help you convert numbers into scientific notation. And now I want to show you one quick example of why it would be important to be able to do this. So let's say that we're talking about how many miles away a really, really far star away is. So let's just say that there's some star out there that is 974 billion miles away. I don't know if there really is a star that's that far away. I'd have to find out. It's probably more than that. I don't know. Okay, that takes a lot of room to write that. I don't want to have to write that over and over and over. A lot of calculators can't show you a number that's that big. So we would say that our decimal's right here, and we want it to go after the first number that is not 0, so that would be the 9 here. And we're going to have to box in all these numbers. Okay, this is when it's important to count them. If you write them neatly, you can count them a little bit quicker, so we can count by 3s with our commas. So 3, 6, 9, and then 10 and 11. So it's going to be 10 to the 11th power, because there's 11 numbers in that box. And then we're just going to bring down the 9.74. So it takes up a lot less room that way. It's a little bit easier to see, and a calculator could actually show this to you, because a calculator is not going to have 12 digits that it can show you most of the time, unless you're using a graphing calculator. So this is why it's important to be able to use scientific notation. Also, if you were looking at things that are really small, it would be useful to show a really, really long decimal. So hopefully this will help you understand a little bit more about scientific notation.